Example 2 asks us to find the range of values of x for which x times the quantity 9 minus x is greater than or equal to 14. So we have x times 9 minus x is greater than or equal to 14. What we're going to want to do in any equation like this is to, because it's a quadratic, and I can see that because we have two linear factors here, it's going to make a quadratic equation. We want to kind of think about it like a regular equation and not an inequality. The answers will come back to the inequality, but our work should start with the equation. So we need to set it up first like a general form of a quadratic. So we're going to simplify and move everything to one side. So with this equation here, we can break this apart, and we're going to have 9x, excuse me, this is an inequality, minus x squared is greater than or equal to 14. Now I'm going to move everything to one side. It does not matter which side you move it to. It'll slightly change the way that you view the problem, but in reality it doesn't matter. I like to have my x squareds positive if I can, so I'm going to move both of these terms to the other side, and what I'll have is 0 will be here. It'll be 0 is greater than or equal to my positive x squared now. I have a negative 9x, and I have my positive 14 is still here. So this is where our problem is right now. Now from here, this is kind of going to be our jumping back to point when we go to answer a question, because we've simplified that original statement down to this. Now, from here, we want to use some analytics and think about what our answer is going to look like. Again, this is a positive x squared, so there's three options for it. It can either be all above 0, it can touch 0 once, or it can go all the way through and touch twice. Now that's going to change our answer, because now we're looking for when is it less than 0. Well, the only time that it's going to be this graph here, it can be 0. So that would give us one answer for this. And then this graph actually is 0 twice, and it also is less than 0 for a little while. So that's going to slightly change our answer. So just giving you an idea of what to look for when you're going through this problem. So we're going to say, because we want to find what the zeros are, or how many there are, we're going to think of it like a normal quadratic equation. Because we have this normal quadratic equation, we can use the quadratic formula to find the zeros, or we can factor, or completing the square. Any of those options work fine. I'm going to factor. Because of the x squared, I have x's that lead my binomials off, and I need two numbers that multiply to make negative or positive 14 that add to make a negative 9. This one's a little bit easier than the last example. So we are going to find that the answers here are going to be negative 2 and negative 7. They multiply together to make 14, add together to make negative 9. So I know that either x minus 2 equals 0, which means that x would equal 2, or that x minus 7 equals 0, and that would make x equal to 7. So our graph here is going to look something like this, where we're going to have 2 here, and we're going to have 7 here. So you can see that the area is going to be between and including these numbers. So at 2, our equation is 0, which we're allowed to have if we go back to the beginning, right? It's allowed to be 0. And at 7, it's allowed to be 0. And everywhere in between is less than 0. So our answers for this problem are going to be x is greater than or equal to 2, and x is less than or equal to 7. Now, both of these have to go together. You could actually write this as 2 is less than or equal to x is less than or equal to 7. These are the only acceptable answers for this that will make this true. If you think about this on a number line, you'd have Um, 2 as where we start. Now this would be a filled in circle because we're allowed to be the value of 2. And then we draw that line all the way until we have a value of 7, which we are also allowed to be. So both representations work just fine. Just again, I would prefer that you write this out, just understanding that that's a range of values, and understanding how to interpret it graphically is important.